Asteroid mining, a concept that has been discussed for decades, with numerous proposals and early-stage missions. Now, whispers in the space industry are getting louder. Could we finally be on the verge of harvesting vast resources from space? And if so, what would it mean for humanity and the mining industry on Earth? Let's take a closer look. For many, asteroids are the stuff of nightmares, massive space rocks that could wipe out life on Earth in the blink of an eye. And that fear isn't completely unwarranted. The dinosaurs met their end 65 million years ago due to a massive asteroid impact. This threat becomes even more concerning as we learn that other catastrophic events in Earth's recent past, such as the Younger Dryas event, are also increasingly linked to possible asteroid or comet impacts. But for scientists, asteroids are more than just potential threats. They are time capsules from the birth of our solar system, offering crucial insights into its formation. And for geologists and the mining industry? Well, asteroids could be a literal gold mine, containing vast amounts of metals, potentially far more than what we have on Earth. What are asteroids? Asteroids are ancient remnants from the early solar system, dating back 4.6 billion years. They formed through a process called planetary accretion, where dust and gas clumped together under gravity. Unlike planets, these space rocks never fully merged into a larger body due to gravitational disturbances, mainly from Jupiter. Over time, asteroids have collided with each other, breaking into smaller fragments, while some have remained relatively unchanged. Most are found in the asteroid belt between Mars and Jupiter, but some orbit closer to Earth, or even beyond Neptune. Why are we talking about asteroid mining again? What's changed? For starters, the entire space industry is on the verge of a revolution. The rapid advancements in AI, automation, and most importantly, reusable rockets are making space travel significantly cheaper and more accessible. AI is improving spacecraft autonomy, mission planning, and resource assessment, making asteroid mining more feasible. Companies like SpaceX are mass-producing rockets at an unprecedented scale, reducing the cost of launching payloads into space. As a result, the commercial space sector is exploding with startups, some of which are eyeing asteroid mining as a major opportunity. So, can we mine all asteroids? The answer is no. Not all asteroids are suitable for mining, at least not yet. While many metal-rich asteroids are located in the asteroid belt, these are still too far for practical mining operations in the near future. It simply takes too long to travel there and back. How do scientists classify asteroids? C-type, carbonaceous. Around 75% of known asteroids fall into this category, rich in carbon and believed to contain water. S-type, siliceous, made of a mixture of rock and metals, comprise about 17% of asteroids. And M-type, metallic, mostly made up of metal. Even though they only represent around 8% of all known asteroids, these are expected to be the most important for mining as they contain vast amounts of iron, nickel, and also precious metals. Asteroids found on Earth are generally referred to as meteorites. Meteorites have been incredibly useful in classifying asteroids. Thanks to these natural space samples, scientists have been able to analyze a wide range of asteroid compositions and gain a rough idea of what kinds of metal content can be expected once a body's class has been identified. Understanding to which class an asteroid belongs is done via remote sensing technologies like spectrometry and radar analysis. While this helps us predict the class we are dealing with, and while meteorite samples give us an idea of what metals we might find in different classes, this is not enough to plan and finance a mining operation. In order to get to this step, asteroid mining companies need a higher degree of confidence in the asteroid's actual metal content. This means that before mining can begin, we still need sample return missions to provide concrete data and give investors enough confidence to support large-scale operations. You may have heard the claim that asteroids are full of gold, but how much of that is true? M-type asteroids do contain valuable metals, but the bulk of their material is iron and nickel. While it's true that they also can contain precious metals, their concentration is comparable to what we can find in our terrestrial mineral deposits. While some asteroids are inferred to be of extremely large volumes, it's hard to imagine that we would process these bodies just to recover large amounts of gold and platinum, as this would also crash prices back on Earth. What is far more likely is that these precious metals will either be mined in smaller volumes or as a byproduct from space-based iron mining operations. In addition to iron, nickel, and precious metals, asteroids are also inferred to hold traces of metals like copper, cobalt, or even rare earth elements. While these metals would likely be mined as byproducts from iron and nickel extraction, they could still prove very valuable for the future space economy, as they are crucial for many parts of an advanced society. Then there is water, perhaps the most valuable resource of all. Certain types of asteroids, particularly C-type asteroids, are believed to contain large amounts of water ice. This water could be extracted and processed into hydrogen and oxygen, key components for rocket fuel. If successful, asteroid-based fuel depots could significantly reduce the costs of deep space exploration, enabling long-duration missions and making interplanetary travel far more feasible. Will asteroid mining disrupt the traditional mining industry on Earth? The answer is complex and depends on the metal. For common metals like iron and nickel, we need millions of tons per year. Transporting such large quantities from space is highly impractical and unlikely to ever outcompete terrestrial production. For the much more valuable precious metals like platinum and gold, things could be different. Because these metals have a high value per kilogram, asteroid mining companies could potentially make a profit even after factoring in the high cost of transport back to Earth. That said, it's important to understand the biggest value of asteroid mining lies in situ resource utilization and not the transport of precious metals back to Earth. The vast resources held in asteroids are crucial for the support of any space-based civilization, as transporting millions of tons of raw material from Earth will likely never be an economic alternative. After early efforts by companies like Planetary Resources in the early 2000s, we are now seeing a new wave of startups stepping up to the challenge. Some of them are currently preparing flyby missions to metal-rich asteroids, with the first ones scheduled for early 2025. Combined with other recent technological leaps, the dream of asteroid mining might finally become reality. So, what do you think? Is asteroid mining just another sci-fi dream? Or will we see the first space-mined metals reach Earth within our lifetime? Let us know your thoughts in the comments below. Don't forget to subscribe for more space-related content and check out the links below to learn more about the space mining industry. And as always, keep looking up.